Hello future engineers, subscribers, viewers, and students. Here is another video about the solutions to the two-D equilibrium problems given as quiz problems. So this is the first. A bar AB of negligible weight is supported as shown below. So this is the figure. At any point along its length, a vertical load Q can be applied. So it may be anywhere on this length AB here. Determine the maximum tension in the cable BC with negligible weight BC by positioning the load Q at the right point. So we position Q in such a way that we are going to satisfy the condition that the tension in this cable BC should be maximum. And common sense dictates that the position of Q to maximize the tension here, it should be away from A so that its moment arm is greatest. So that Q times its greatest moment arm equals tension times moment arm also. So if the product of Q and the maximum moment arm, the product of Q and the maximum moment arm will give us the maximum moment, and it should be divided by the distance which is fixed. So it means that for maximum tension in BC, Q should be placed at B. So this is now the free body diagram, and the tension in BC corresponds to the maximum tension. So this is the free body diagram. We have AX and AY at A, unknown reaction components, but we plan to sum up moments about A. So the distance horizontally of point B from the wall is equal to L, because the length of bar AB is L times cosine of 60 degrees, or that is 0.5 L. While the vertical distance of A and B, the vertical distance between them is L hypotenuse sine of 60 degrees. T has two components. One is vertical, T sine of 75 degrees. So this is 15 degrees. 60 plus 15 is 75. So the vertical component of the maximum tension is T sine of 75 degrees, and its moment about A is counterclockwise, while the horizontal component is T cosine 75, and its moment about A is clockwise. Just like the moment of Q, it's clockwise. So counterclockwise moment about A minus clockwise moment about A equals 0. So the counterclockwise moment is the vertical component of T max sine 75 degrees, and the moment arm is L cosine 60 degrees, then minus the horizontal component, which is clockwise, T max cosine 75. The moment arm is L sine 60 degrees, then minus the moment of Q times L cosine 60 degrees equals 0. Combining terms with T max, that's 0.35882 T max, and transposing this to the right after we cancel out L, common to all terms, so that's Q cosine 60 degrees, and Q cosine 60 degrees is 0.5 Q. Dividing 0.5 Q by 0.35882, then we get T max equals 1.932 of Q. So that's it for that problem. So for this second problem, in the figure shown below, this figure here, the small blocks A and B respectively weigh 2 to 3 newtons, A and B 133 newtons, and the planes are smooth. So these planes are smooth, so no frictional resistance. The connecting rod is light, so this is light, and because the ends are pin-ended, then this is a two-force body. Letter A, find the force P that will hold the system in equilibrium, this P here. And B, repeat the problem with P applied instead horizontally to block A to the block A. So P is applied here for the second part. So for the first part, this is the FBD. Let's call the force in strut AB as F. This is the free body diagram of A, weight 2 to 3 newtons. Then that's the normal reaction, that is F. Since there's no frictional resistance, summation forces X equals 0 supposedly. So that means X component of F, which is to the left, is negative F cosine 28.07 degrees. By the way, inverse tangent of 8 over 15 is 28.07 degrees. I'll call the angle of inclination here as theta, so that is theta. Opposite to theta is 3, adjacent 4, so the hypotenuse is 5. Take note of that. So X component of F, negative F cosine 28.07 degrees, then plus nothing equals 0. So that means F is 0 because cosine 28.07 is not 0. Then we transmit F in this free body diagram of body B. Take note that F is 0, so we don't mind. Then this is the normal axis. If that is theta, the angle between the weight 133 and the normal is also theta. So since F is 0, summation forces along the tangential axis where P is directed to is 0. So P minus or equals this component of 133 newtons, that is opposite of theta, because this is theta supposedly, equal to that. So 133 times sine theta, and sine theta is 3 over 5. Opposite of theta, 3, hypotenuse 5. So 133 times 3 over 5. From there, we can solve for P, 79.80 newtons. Then for part B, P is now applied horizontally at A. So this is now the free body diagram. And for the right part, this is the free body diagram. Now, this line F prime has a value, so that the angle here is 28.07 degrees. Inverse tangent of 3 over 4 is 36.87 degrees. So one systematic way, because there are two unknowns here, the angle that NB makes with the vertical is also theta. So you may just apply the two equations of statics, namely summation forces along X equals 0. If that's your equation, then the first equation would be F prime cosine 28.07 degrees minus NB sine theta. The X component of NB is NB sine theta, where sine theta is 3/5. Then minus along X, so equals 0 because 133 is downward. So that would be first equation, F prime cosine 28.07 degrees minus NB times 3/5 equals 0. Call that equation 1. Then summation forces Y equals 0. F prime sine 28.07 degrees plus NB cosine of theta, and cosine theta is 4/5, so plus NB times 4/5. First term is F prime sine 28.07 degrees plus NB times 4/5 equals 133. Equation 2. Solve the two equations simultaneously. You will get F prime. If F prime should be 80.75 and NB may be somewhere any other value. But what is important is F prime. That's the important value that should be considered. So 80.75. It should be 80.75. But I solved F prime directly by summing up forces along the tangential axis so that NB is not involved. Only one unknown is involved, if F prime. So since this is 78.07 degrees and the inclined plane is making an angle of arctan 3/4 or 36.87 degrees, this is the line parallel to this inclined plane. Therefore, the angle here is 36.87 minus 28.07 degrees, and that is 8.8 degrees. Then summation forces tangential equals 0. f prime times cosine 8.8 degrees equals this component, which is 133 times sine theta, which is 3/5. So f prime is 80.75 newtons. Then let's draw this, going back to this free body diagram. Summation forces horizontal equals 0. So P equals the x component of f prime. And the x component of f prime is f prime 80.75 cosine of 28.07 degrees. So solving for PT is 71.21 newtons. So that's it for this video.